Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are moving forward to the lesson of the chapter of the atomic physics with the next lesson, which is the strong nuclear force. We discussed the nuclear physics main things, introduction part in the previous lesson. Now we move on to nuclear force and start moving to the mass defect, which is the way doing one formula of the Einstein equation and how to find the mass defect and all the things written. Strong nuclear force is the main topic of this. We discuss that topic at the end too. So let's start with some calculation. Let us look at the force of gravity and see if it's a candidate. For the force of gravity to keep the nucleus together, the ratio between the force of gravity and the electrostatic force is this must be at least 1. We will examine the interaction between the two protons. Why we're doing that? Because of we want to say that is the uh, is the force which binds the nucleus has a strong nuclear force or not. If it is at least 1, so they can have the gravity keep the nucleus together. So that's all the evidence we have to collect to find the that is right or wrong. So we will do the calculations quickly. So Fg upon Fe, the force of gravity upon the electrostatic force. The force of gravity, you all know that from the grade 10, which is g m square. We will use the mass of the proton in this upon r square divided by the electrostatic force, which is k q square upon r square. We use the proton ones with the q square because it is same. So the g is the value of 6.6 in 10 raised to minus 11 Newton meter square kg square. 1.67 10 raised to power minus 27 kg square. Then r square cancel from here. That whole thing divided by the 8.99 to 10 raised to power 9 meter square. Coulomb square, that should be divided by the 1.6 in 10 raised to power minus 19 coulombs. When you calculate this, you get 8.08 into 10 raised to minus 37 with no units. So basically, that thing you don't have to know. We have to just calculate this for doing some evidence part. So start moving to the strong nuclear force theory part of this. So given how weak the force of gravity is, it is quite clear that gravitational attraction is not responsible for keeping the nucleus together. So is that the reason we have to behind this, that the gravitational force is not responsible for the nucleus being together. The protons and nucleus are in the nucleus that bind the nucleus is not the reason that they have a gravitational attraction force. The force that actually keeps the nucleus together is something we have not yet taught about, but is one of the four fundamental forces of the universe, electromagnetism and the gravity being two of the fourth. The force that binds the nucleus is a strong nuclear force. So we have four fundamental forces. We discuss that topic by the end of this unit 2. But the four fundamental forces, the electromagnetism and the gravity is the two of the fourth. But the third one we have that this is the force which is called the strong nuclear force, which is actually binds the nucleus. Actually force that binds the nucleus with the protons and neutrons. So that's the new force we introduce in today's lesson. The strong nuclear force is the force of attraction that acts between a two pair of nucleons, which is a proton and the neutrons. They doing that force of attraction which acts between any two pair of the nucleons. This force has a very short range, so it can have any effect on the particles at a few femtometers apart, and after a distance has been achieved, the force can be negligible effect. So that's the whole thing. That thing you have to know in this too, like which force binds the nucleus? Strong nuclear force. And the strong nuclear force is the force of attraction that acts between any pair of the nucleus, not any other thing. That's the thing, because we have to know that which force is attracting to the atom or to the nucleus, which is the strong nuclear force in that case. And this is the third force we discussed now. Let's move on to the main topic of today's, which is the mass defect. So, mass defect, this in the stable nucleus, this is again involving the nucleus. In the stable nucleus, the total mass is always less than the sum of the mass of the constitutive nucleons. which is the protons and the nucleus. So total mass we calculate is always be less than the sum of the masses of the protons and protons and the neutrons. The carbon-12 has the mass of this. The nucleus itself is composed of the cis protons and the cis neutrons. If it is added up to the mass of the constitutive parts, we get this. So when the particles are bond, there is a addition of the mass of this, defective of the sum time. The difference in the mass known as the mass defect. So that's the thing, the mass defect introduced in that. The mass defect, which is called the delta M, which is equal to the mass of the nucleons minus the mass of the nucleus. Mass of nucleons minus the mass of the nucleus. So that's the main thing, that's the mass defect, and we have to deal with that formula again and again. But delta M. Delta M is used in the Einstein equation too. That we also use to find the energy of anything. So in 1905, Albert Einstein opposes the part of a theory of the special relativity. The mass itself was another form of energy. The mass lost in nucleus when it assembles and converted to another form of energy. To calculate this equivalent energy, Einstein introduced what is likely the most famous formula in all of the physics, which is called the mass energy equivalence. The energy is equal to the delta M, which is the mass defect, and C squared. Mass defect in kgs. Law of conservation of mass energy is the principle in that, which is the physics principle number 6. This is the conservation of mass and energy. C is the speed of light, and E is the energy converted from the mass. So energy converted from the mass in joules we take, not in EV. We always say it in joules. So that's the Einstein equation, and we use that equation again and again. So we have example over there to deal with that things. There were two formulas. And nuclear force, strong nuclear force is very important in that. The mass defect, why we use that formula is very important. So the both formulas we have to use, and yeah. So let's do this question. The mass of an oxygen cysteine nucleus is 15.9949 U. The mass of the individual proton is 1.0073 U and 1.0087 U for the neutron. You have to find the binding energy per nucleon oxygen in the oxygen nucleus. So what is called the binding energy? Binding energy is not anything else, this EB, just EB. We have to find for per nucleon, which is A. I will discuss that. What is that? So at the end we will discuss that. So firstly we have to find something else. We have to find the energy. For energy we want a defect mass. We want defect mass, but we don't have defect mass effectively. We have to find this. So we have a oxygen cysteine, which is basically this thing, and the atomic mass is 8. So which things are given to us? So let's find the what things we have. So basically we have a Z, which is 8 is given to us, and we have a A2, which is 16. So we can find the N from here, which is A minus Z, where we get N of 8. That is what we use. So firstly, we have to find the mass of the nucleons, because we have the mass of the nucleus is given to us. We have to find the mass of the nucleons. So the mass of the nucleons is equal to. So we have to find the mass is the mass of the. We have to find the Z and N, which is the mass of the. We have to find divide this by the Z, which is the mass of the proton, multiply by it, and the N, the mass of the neutrons. So to find this, Z is given to us 8. Mass of the proton we have 1.0073 plus N is 8, and we have a 1.0087 of this. So when you find this, and you will get a 16.1280 U. We get this in U. So we have a mass of nucleons, we have a mass of nucleus, so we can find the defect mass now. So the mass of nucleons minus the mass of the nucleus. So 6.1280 U minus 15.9949 U. When you find this, you get about 0.1331 U. But to use this mass in the energy formula, which is you have to find the binding energy, which is EB, DEFECT mass C square. Your DEFECT mass should be in kgs. So to divide this into kgs, you have to multiply this with 1.66 into 10 raised to power minus 27 kgs divided by the 1 U. You cancel out, and you will get a DEFECT mass of about 2.20946 to 10 raised to power minus 28 kgs. You have to convert this. So this is equal to the 2.20946 into 10 raised to power minus 28 kgs, and we have a C square of this. When you find this, you get about 1.9885 into 10 raised to power minus 11 joules. But you want the binding energy per nucleon in the Gaussian channel. So what is mass? What is a nucleon? Nucleon is represented by A. And what is A? So to find this by A, you have to divide this by the A, which is T. When you divide this, you get this thing, which is 1.243 into 10 raised to power minus 12 joules per nucleon. So that's the thing you have to do at the last, which is very important, which is like tricky part in that. You have to just not stop over there. You have to find that you have to divide this by the A, which is per nucleon. So that's the answer. You want fourth set this, and this is your answer. So that's how you can deal with the DEFECT mass and the mass energy equivalence, which is Einstein's equation. Very important questions. That's again involving these things, Z and an A. This is a whole core thing we discussed in the nuclear radiation terminology in the previous lesson. So watch that lesson first, then you can see that how this questions works in that case. So that's all for this lesson. And finally, in the next lesson, we start with radioactive thing, which is radioactive decay. Radioactive decay is a big topic, so we cover in the 2 lessons. So you have to watch this lesson, both lessons. First lesson we deal about the more theory part of the radioactive decay, and the second lesson we deal with some theoretical part, some any calculation part, or some other things. So this lesson is for all. So let me see if EduVibe learns but not harder. Please like and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till let's get it with EduVibe.